Hi guys, sorry I couldn't be there today, but I thought this would be the best way to make sure that we don't get behind. So let's get going. So today I'd like you to do textbook page 687, 8 through 24. I apologize that we don't have any stamp sheets right now, but I'll get you a stamp sheet probably on Wednesday. I'm hoping to be back on Wednesday. So can you go ahead and turn in your lilac stamp sheet for me, please? Pick up a calculator if you don't have one of your own. Take out a piece of paper for notes and go ahead and write down tonight's homework somewhere. Okay, let's talk probability. So a trial is something like flipping a coin or throwing a die or, of course, whether or not you're going to have a boy or girl. Sample space. Sample space is the set of all outcomes. Outcomes meaning the result of a trial. And we'll talk more about all of this. An event is one or more outcomes of a trial. So let's talk about this. Okay, so for instance, a trial would be whether or not you're going to have a boy or girl. This experiment says if you have 3 babies, how likely are you to have 2 girls and 1 boy? Well, we talked about this in last chapter. The likeliness of having a boy or a girl is a 50-50 shot, right? Or there's 2 different outcomes and 2 different outcomes and 2 different outcomes. All of those outcomes put together would be the event of having 3 children. So let's continue our talk. I'll be able to use the fundamental counting principle to find all the possible ways multiple events could occur. I'd like you to be able to explain the difference between an independent and a dependent event. And this first lesson should be pretty easy. I'm not too worried about not being there for this one. Okay, so a cafeteria offers drink choices of water, coffee, juice, and milk, and salad choices of pasta, fruit, and potato. How many different combinations of drink and salad are possible? So there's a couple of different ways that you can look at this. You can look at it as you've got a possible water, or you can have coffee, or you can have juice, or you can have milk. Now, once somebody decides whether they're going to have water, coffee, juice, or milk, then they have 3 more options. They could either have, the person that had water could have pasta, fruit, or we'll just, since they're both P, we'll say potato will be an O. The person that picked coffee also has 3 different choices. The person who picks juice also has 3 different choices. And the person that picks milk has 3 different choices. So if I were to actually write all of these out, it would be water and pasta, water and fruit, water and potato, or coffee and potato, coffee and fruit, coffee and, or this was pasta, coffee and potato, or, let's start right here, juice and pasta, juice and fruit, juice and potato, and finally milk and potato. Sorry, pasta, I keep saying that. Milk and fruit, milk and potato. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 different ways. But there's something called the fundamental counting principle that says I can write it out like this. I've got 4 different choices times 3 different choices, so 4 different drink choices, and 3 different sides. Fix this here. 4 different drinks, 3 different sides equals 12 total outcomes. So it's pretty simple. Much easier than drawing yourself a tree diagram and counting them all up. Alright, Janine has decided to buy a pickup truck. Her choices include either V6 engine or V8, those two choices, two different outcomes, a standard cab or an extended cab, two different choices, and two-wheel drive or four-wheel drive. Two more choices. How many possible models does she have to choose from? She has 8. So here's the fancy definition. If an event M can occur in M ways and is followed by an event N that can occur in N ways, then event M followed by event N can occur M times N ways. A briefcase lock has 3 rotating cylinders, each containing 10 digits. So here's our briefcase lock, and each one of these right here has 10 different digits. How many numerical codes are possible? Well, I've got 10, then another 10, then another 10. That's 1,000 possible codes. Let's try this one. How many 7-digit phone numbers can be found in the first digit, if the first digit cannot be 0 or 1? Okay, we've got 7 different digits. 1, 2, 3, 4, 5, 6, 7. So how many 7-digit phone numbers can be formed if the first digit cannot be 0 or 1? Well, if we're talking digits, there's 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0 is 10 different digits, but it can't be 0 or 1. So I don't have 10 possibilities, I have 8 possibilities in the first one. And any digit can be repeated. Okay, well, if I can repeat it, and I started, let's say, off with the first digit is 9, well, I can repeat 9 again. So we've got a total of 10, another 10, another 10, another 10, another 10, and another 10. So we actually have 2, 3, 4, 5, 6 zeros. 1, 2, 3, 4, 5, 6. So 8 million different possibilities. How many 7-digit phone numbers can be formed if the first digit cannot be 0 or 1? We figured that out. And no digit can be repeated. Well, if there's 10 total digits and I already used one of them up, then I only have 9 left, and then 8 left, and then 7 left, and then 6 left, 5 left, and then 4 left. 1, 2, 3, 4, 5, 6, 7 digits. And I've already worked that out for you. That would be 483,840 different numbers that could be formed. Okay, so what are the differences between these two? Obviously, this one's different than this one. More outcomes if it's independent events. One event does not affect the event of the next trial. It makes more outcomes. Dependent events are the event of one trial affecting the event of the next trial. So the fact that we could already use up one of the digits, we couldn't use it again, affected these numbers here. Hopefully that makes sense. Alright, so let's do these. I'm going to try and pause for a second so you guys can call out whether it's independent or dependent. Choosing the ice cream flavor and choosing a topping for the ice cream. Is that independent or dependent? That one is independent. It doesn't matter which ice cream flavor you have, if that has nothing to do with which topping that you're going to choose. Well, it does, but it doesn't. Alright, so choosing an offensive player of the game and a defensive player of the game in a professional football game. Does it matter who the offensive player is if the defensive player is going to be somebody else? Well, it may matter to a coach, but choosing all the different events would be definitely independent. From 15 entries in an art contest, a camp counselor chooses first, second, and third place winners. That is definitely dependent, because once somebody gets first, they're out of becoming second or third. You can't be first, second, and third. Jillian is selecting 2 more courses for her block schedule next semester. She must select one of the 3 morning history classes and one of 2 afternoon math classes. This one's a little bit more difficult, right? Well, this would also be independent, because she has morning classes that she has history, and then she has afternoon classes that are math, but these 2 don't have anything to do with each other. They are completely independent. All right, the fundamental counting principle still applies. There are 5 different routes that a commuter can take from her home to the office. In how many ways can she make a round trip if she uses a different route coming than going? So if she's got 5 different options when she's going, then when she comes home, since she already used one of those options, she only has 4 different options to come home. So that would be a total of 20 different outcomes. Let's look at this one. In how many ways can the 4 call letters of a radio station be arranged if the first letter must be W or K and no letters repeat? So the first one, they talk about 4 letters, 4 call letters, and the first one has to be W or K, so that's 2. There's 26 letters in the alphabet, and we can't repeat. So we already used 1 up, so then I only have 25 letters left, then 24 letters left, then 23 letters left. So that would be 27,600. Let's see, I think this is my last one here. All right, so the 10-member steering committee that is preparing a study of the public transportation needs of its town will select a chairperson, a vice chairperson, and secretary from the committee. No person can serve in more than 1 position. In how many ways can the 3 positions be filled? So we've got 3 different positions. There's 10 members. Once one of those members is picked for the chairperson, only 9 are left to choose for the vice chairperson, and then only 8 are left to choose for secretary. So 720 different ways that can happen. Okay, so when we get your stamp sheet, we'll fill this out. But I hope that you guys are ready to get your homework done. Work together, work hard. I'll put the answers online for you.